Welcome everyone. Today we are going to navigate through the fascinating world of the GPU's white papers. The white papers are essentially the datasheets or the in-depth technical specifications of the GPU's architectures. These documents, the white papers, are invaluable when it comes to comparing different GPUs because they offer a detailed insights into each architecture's specifications and capabilities. Returning to this table here, you will notice that for each architecture, we have an example of a chip that is based on this architecture. To obtain the white paper of any architecture, all it takes is a simple internet search. Just open your browser, write the chip name followed by the word white paper. And the chip name can be brought from this table. Okay, so it is easy. And once you do this, you are likely to find what you are looking for. You would search for GF100, the chip name from the table, and then write white paper. Once you do this, click enter and you will be presented with a list of results. You need to look for the PDF file, the PDF file that represents the official white paper. And as you see, we have the white paper of the GF100 chip. Similarly, if you are investigating the Ampere architecture, you would search for GA100 white paper. Remember, the link you are looking for should lead you to a PDF document that contains the full technical specifications. Because sometimes you might stumble upon articles or summaries, but what you want is the original full-length white paper. As you see, we have the PDF file of the GA100 chip white paper. Now, let me take you to another important point in this video. Nvidia has a helpful practice of comparing their new architectures against the previous ones in their white papers. So, if you're reading the white paper for the A100 GPU or the GA100 chip or the Ampere architecture, then you are likely to find a performance comparisons with its predecessors like the Volta and Pascal, the V100 and the P100. This is why we have an interesting observation in which certain tables and figures can be found in different white papers. For example, you might come across the same table that shows the different units and metrics in the white papers of the P100, the V100, the A100, and the H100. This consistency in all white papers, as you see now, means that once you understand how to navigate and interpret only one NVIDIA white paper, then you are well equipped to understand other white papers. But let me tell you something, it doesn't stop there. NVIDIA's white papers typically follow a standardized structure that includes the following points in order. The first point is the introduction of new features. The second point is the streaming multiprocessor internal components and structure. The third point is the performance benchmarks and comparison. The final point is the technical specifications. Let's start with the first point, the introduction of new features. Each white paper begins with a section highlights the novel technologies and enhancements. This could be anything from new types of cores like the tensor cores for the artificial intelligence computations to improved shading technologies for graphics or even any enhancement in the software or hardware. The second point is the streaming multiprocessor internal structures or components. All the white papers delve into the architecture of the new streaming multiprocessor. Then we have the performance benchmarks comparison. As you see in these images that I brought from different white papers, we have a different comparisons for each architecture with its predecessors. Finally, we have the technical specifications. A detailed specifications including the core count, the memory size, the memory bandwidth, the memory technology, the power requirements are existed in all white papers to give a comprehensive view of the GPU's capabilities. So now these are the main 4 points that you are going to find in each white paper. We are going to focus on point number 2, the streaming multiprocessor internal structure. Starting with the streaming multiprocessor internal structure or the internal components. Nvidia's white papers provide an in-depth look at the SM design for each GPU. For example, if you examine the white paper for the Pascal-based P100 GPU, the white paper of the GP100 chip, you will notice a picture for the entire GPU here as shown. Then we have the common comparison table that we already discussed. Then we have the streaming multiprocessor detailed diagrams and the description of its internal components, such as the CUDA cores and the memory hierarchy. When we transition to the V100 white paper or the Volta architecture white paper, a similar layout is present. For example, we have here the entire GPU. Then we have the comparison table. And finally, we have the internal structure or the internal components of the streaming multiprocessor. However, here you will observe a notable enhancement, which is the addition of the tensor core units. As you see here, we have the tensor core units in the Volta architecture, but in Pascal there is no such units. Now let's move on to the A100 white paper or the Ampere architecture white paper. Again, this white paper shows the entire GPU, and then we have the details of the streaming multiprocessor internal structure. But we don't have the comparison table because they moved the comparison table in another section. But anyway, we have it in the white paper. Then, as you see, the layout in the Ampere architecture may seem familiar because it is quite similar to the internal structure of the streaming multiprocessor in the Volta architecture. Just look at these two pictures here, you will see that there is a huge change. This consistency holds as we look at the H100 white paper or the Hopper white paper. This white paper presents the entire GPU as you see here. Then this GPU architecture is followed by the details of the streaming multiprocessor internal structure. And as you see, the main difference between this architecture and all predecessors is the number of cores available in each SM. For example, you can count how many floating point 32-bit cores here in this architecture and compare it, for example, with the A100 GPU to see the difference. Okay, now to sum up, I want to say that while each white paper is unique to its GPU, the structure and the type of information provided in all white paper follow a similar pattern. This continuity or this consistency not only makes it easier for professionals to keep up to date with the latest technology, but also enables a clear understanding of the advancements and how each new architecture stacks up against its predecessors.